Hello, my name is Jason Bard, and this is my poster about diagnosing autism using machine learning. Given that I have autism, this project has been fascinating to work on, and I feel grateful to be able to work on a project like this that might move the bar in the direction of helping the most amount of individuals with autism. Now, autism spectrum disorder, also known as ASD, can be characterized by an individual's impairment of their social ability and by having repetitive interests and/or behaviors. It's typically diagnosed in patients between 18 and 36 months of age, and the severity of symptoms can vary widely. While there's currently no known cure, early intervention and treatments such as behavioral and speech therapy can help people develop skills and abilities that allow them to be social and to, say, present a poster at a conference, for instance. Research has shown that there are differences in brain structure and function in individuals with autism. And while the specifics aren't fully hashed out, we do know some basic parts about how different brain regions affect a potential diagnosis. The ABIDE dataset, which stands for the Autism Brain Imaging Data Exchange, is a collection of publicly available brain imaging data provided by dozens of universities and medical imaging sites. It consists of over 1,000 patients near evenly split into two groups, those in a healthy control group and those who have been diagnosed with ASD. The dataset as a whole includes both resting state and task-based fMRI data, in addition to clinical and demographic information about the participants, such as age, gender, IQ, handedness, and diagnostic information relating to test scores and researchers' and interviewers' observations. In this study, I used the Python package nylearn to transform these RSfMRIs, as they're known, into time series using the Harvard-Oxford Cortical Atlas via a masker to determine potential regions of interest, such as the amygdala or orbital frontal cortex, or OFC. Specifically, I only looked at the OFC, but I may look at the amygdala in the future, given that it is also a region that has been looked at to determine whether or not individuals have autism. As the poster says, I used 80 patients that were scanned at NYU, and here you can see the brain scan from one of them in three cross sections. And just below that, we can see the change from mean blood flow for one of the patient's OFCs. Now, I ran 1,000 simulations of one instance of a multi-layer perceptron classifier, also known as an MLP classifier, and the results that I got consistently showed about 50% accuracy with a max accuracy of 81.25%. Precision and recall each showed similar results when it came to the average, except both categories showed a maximum of 100% and a minimum of 0% during many runs. This could show that there's no reliable way to diagnose based off this region alone, but there's a more likely explanation. I was limited by the small sample size due to the hardware and software I was using, though. The smoothing process really took a toll on my laptop's RAM, and even using Google Colab's GPU gave me some difficulty. If someone wanted to make a bigger study exactly like this, I think they'd need a larger machine than just my laptop. The entirety of the dataset takes up over 100 gigabytes of disk space storage, and using 80 patients took up only 8 gigabytes that I was able to load. In addition, the patients in this study were from only one center, and I think that using patients from multiple brain scan centers, as actually provided in the dataset, could contribute to a higher accuracy in the future. Furthermore, using the subcortical atlas to explore the amygdala would be helpful, given that it's also connected to research about autism diagnoses. Doing all these things would make future models much more successful, putting them on par with current cutting-edge research levels. I hope to make some of these models in the future as well. A big thanks to Dr. Maya, who's helped me find my footing throughout this project, as well as Dr. Farbin and the team of undergraduate and graduate researchers who've helped me learn more about research itself in general in our weekly meetings. Thank you all, and I will see you at the symposium.